Welcome to Build Wealth Logically. Your path to financial growth starts here. Calculate, invest, and grow.
Underneath all the noise of our daily lives, there's this low, constant hum. It's the sound of a completely invisible world, a hidden nervous system of code and machines that makes basically everything, from the cement in our buildings to the bread on our tables. So today, we're going to pull back the curtain and take a look inside. To get inside, we followed a veteran engineer named Omondi. He walked us through one of these doors you never notice in a big cement plant in Kenya. We went down these concrete stairs into a place where the factory is really alive, a place where decisions get made faster than any human could possibly think.
40 milliseconds. That's how fast the factory's brain, it's called a programmable logic controller, or a PLC, reacted to what could have been a total disaster. It saw a temperature spike, it instantly calculated the thermal stress, and it diverted a literal river of molten material. The whole crisis was over before a person's pager would have even started to vibrate.
So, what does a brain like that actually look like? Well, picture a room about the size of a basketball court, and it's chilled to a perfect 18 degrees Celsius, and it's just filled with these rows and rows of humming, blinking steel cabinets. This isn't just some machine room, this is the real central nervous system of the entire factory.
And this is where it gets kinda wild. Omondi points to just one of these cabinets. Inside is the code that runs an 800 million shilling a day operation. And that code, it was written back in 1998. The original manual is literally held together with electrical tape.
To really get how this is even possible, we have to basically become digital archaeologists. We're about to dig down into the layers of code that are the bedrock of our industrial world. We're talking about a language that's older than most of the people who have to maintain it now.
And this is what they're using. It's called ladder logic. See, it was designed way back in 1969 to look just like the electrical wiring diagrams that electricians already understood. It was visual, it was simple, and that simplicity is exactly why it's still around, running some of our most critical infrastructure more than 50 years later. And this is a perfect example of how these systems evolve over time. Okay, so some programmer, let's just call him Steve, writes the original code back in 2008. Then, over the years, other people come in and they add patches, they add workarounds. Then, in 2019, a whole section of the plant gets demolished. But the code to check on its sensors, nobody ever deleted it. It's still running, right now, pointlessly checking for a sensor that isn't there.
Omondi had this perfect metaphor for it. He said the code grows like coral, layer on layer. It's living history. They never delete old code, just in case it breaks something else. So it all just builds up, a fossil record of every crisis, every shortcut, and every temporary fix from the last few decades. It's less like engineering and more like excavating a ruin.
And this isn't just theory. Check this out. At another factory, a textile factory, a big conveyor belt would just stop. Every 47 minutes, like clockwork. What was the cause? Well, turns out it was a temporary fix from 2011, left behind by some engineer named JK, who'd even left a comment in the code. It said, "To do, fix this properly." He never did. And today, the entire factory's maintenance schedule is literally built around that bug.
Okay, so that's what's happening down in the humming, blinking machine room. But what about the people upstairs in the control room, the ones who are supposed to be in charge? Well, this is where you start to see this huge gap between what the machine knows and what the human actually sees.
Just follow the sequence of events here. A pump starts vibrating. The PLC down in the basement detects it, compares the signal to some thresholds that were set back in 2014, and makes a decision to issue a warning. A full 45 seconds later, an operator named Wanjiku sees a little light on her screen change color. The decision, the crucial moment, it's already long gone.
And this gets to a really fundamental misunderstanding about these systems. The operators in those fancy control rooms, they're not really commanding anything. They're more like translators, or maybe even historians. They're just interpreting decisions that were already made, downstairs in the dark, at the inhuman speed of the machine. And this difference in philosophy, it has huge consequences. Let's take two bakeries, both with the exact same technology. Bakery A's philosophy is, we bought monitoring. They use their system to look back and see what broke yesterday. But Bakery B's philosophy is, we bought understanding. They use their system to ask questions like what almost broke or what changed in the 3 minutes before that thing almost broke. One is just managing decline, the other is expanding.
And the result of that simple shift in thinking? A 23% gain in efficiency. Not from buying new hardware, not from some fancy upgrade.
It came from a new sense of curiosity. It came from building a conversation with the machine, instead of just letting it file a report about what it did yesterday. But sometimes, these layers of old tech create problems that are, well, they're just plain weird. They can create ghosts. We got called to one factory where the main conveyor would just stop, completely at random. No mechanical fault, no electrical issue, and security footage showed nobody was even near the stop button.
The engineers were totally stumped. I mean, the logs clearly said operator stop, but the cameras proved no one was there. The whole mystery finally cracked open when we started asking a different kind of question. What happens when systems that were never ever designed to communicate accidentally find a way to talk to each other?
And here it is. Here's the ghost. There were 3 separate PLCs from 3 different decades, all linked together by a supposedly temporary cable someone ran back in 2014. It turned out that every 2,847 seconds, that's 47 minutes and 27 seconds, their internal clocks would align perfectly. When that happened, it created a tiny power surge on that shared cable, just enough to trick a safety sensor into thinking an emergency stop button had been pressed.
So it wasn't a malfunction, not really. It was an emergent property. It was a feedback loop created by decades of layered-on solutions. It was a perfect, invisible, mathematical haunting.
So if our industrial world is built on these invisible, sometimes haunted layers of code, what do we do about it? I mean, do we just keep slapping on more patches and creating more ghosts for the future? Or is there a better way to think about this?
You know, I was teaching a class on PLC programming recently, and a student just cut through all the complexity and asked this incredibly simple but really profound question. He just said, if the systems are broken, why don't we just build better ones? It gets right to the heart of it, right? Why should we just accept the ghosts of the past?
And better doesn't just mean faster or more powerful. It means building systems that anticipate problems instead of just reacting to them. It means systems that can learn an operator's patterns and protect them from fatigue. Systems where transparency is baked in from the beginning, not added on later. We need systems that can admit what they don't know. And, this is crucial, they need to be designed for here by the people who will actually be here to fix them.
The real goal is to finally break this cycle of temporary fixes that just become permanent, generational problems. And efforts are starting. A project called Vault, for instance, is trying to build these new principles right into the DNA of our industrial systems, creating a foundation that's actually built on purpose, not by accident.
And that really leaves us with a final thought, doesn't it? That hum beneath the factory floor is made of decades of accumulated decisions, human shortcuts, and forgotten histories. It's a powerful reminder to just stop and ask, what other invisible systems are running our lives, and how well do any of us really understand the ghosts that might be living inside them?
If you believe wealth should be engineered, not guessed, like this video, subscribe, and hit the notification bell so you never miss the next strategy.